In the past session, we learned how to estimate the population mean when we assume we know the population standard deviation and sample size is bigger than 30. If this condition cannot be met, in other words, we don't know the population standard deviation at all. And in this case, we don't need n to be bigger than 30. Then we have a different way to estimate. When we do not know the population standard deviation sigma, we use sample standard deviation S to estimate sigma. Now we're doing two estimations at the same time. The first estimation we're doing is we use sample mean x bar to estimate population mean mu, and then we use sample standard deviation S to estimate the population standard deviation sigma. Again, we use sample standard deviation S to estimate the population standard deviation sigma. In this case, because we are doing two estimations at the same time, normal distribution is not accurate enough. Now we're going to use t distribution. Now, what is t distribution, you might ask? Another name for it is a student's t distribution, because the person who founded this, his last name is a student. So we also call it a student's t distribution. Anyway, it's a t distribution. What is it? T distribution is a probability distribution very similar to normal distribution. Be careful, later on we're going to talk about one thing as degree of freedom, which will equals to n minus 1. When I show you how to use the table, it will become clear. There is a t distribution table. Let's move on to use it. Now here comes an example of t distribution. T distribution looks very similar to normal distribution. It works similar to normal distribution as well. So we're going to see a curve looks like this. All right. And the area under the curve is the probability. Now assume that in this example, we're going to have a tail here. The size of the tail is 0.05. And we try to find the value of this point on the axis. Now, we assume that the sample size equals to n. For all the t distributions, degree of freedom equals to n minus 1 equals to 2. So it is always the case. So n minus 1, n equals to 3, 3 minus 1 equals to 2. Now, in order to find the value of this point, we go to the t distribution table. And first of all, we find in the first column, we use the degree of freedom. We know in our case, degree of freedom equals to 2, so find 2 here. Now, the upper tail area here is given as 0.05, so we find 0.05 here. Okay, this size of this area is 0.05. So, goes down this column, and when a degree of freedom equals to 2, we're going to find it 2.92. And this 2.92 is the value of this point. Goes beyond this point. The highlighted area goes beyond this point, has a probability of 0.05. That's how it works. Again, in the body of the t distribution table, it gives us the value on the t-axis, which is this horizontal axis. This body of the table gives us the location on this axis. In our case, it is here. the probability is on the top row, it's right here. Okay, this is the probability. So when we know the probability, we can find the point right here. Now, let's do an in-class exercise of this t-distribution. Please use the t-distribution table on page 800. Now, let n equals to 16. Please first calculate degree of freedom. Now, when we know the degree of freedom and the size of this tail here, which is the probability equals to 0.025, please find the value of this point in the t-distribution table. It's basically in the body of the table. Please stop now and take your time to finish these in-class exercise. Now, here's the answer. Since we know n equals to 16, then degree of freedom always equals to n minus 1. So n minus 1 equals to 16 minus 1 equals to 15. In the first column, we first find degree of freedom, which is 15 here. And then in the area in upper tail, so be careful, you first find the area in upper tail in the table, and find the value here, which is 0.025. So 15, the row of 15 goes to 0.025. This value is 2.13. Now we're ready to estimate the interval estimation of a population mean. And now we do not know the population standard deviation. So here's the formula: x bar plus minus t alpha over 2 times s over square root of n. Now, 1 minus alpha, again, similar to what we learned in the last session, it is the confidence level. And we have a t alpha over 2, which we're going to see soon. And we use s, the sample standard deviation here. So if you have time, please take a look at the case where we know the population standard deviation in the last session. Take a look at the formula over there and see the difference will be here and here. We're going to apply this formula to an example. A reporter for student newspaper is writing an article on the cost of off-campus housing. A sample of 16 efficiency apartments within a half mile of campus resulted in sample mean of 650 per month and a sample standard deviation of 55. Now, first of all, the sample size is 16. It is not bigger than 30. Second, thus we do not know the samples, the population standard deviation. We only know the sample standard deviation, which is a 55. In this case, we do not know population standard deviation sigma. Now we are asked to provide a 95% confidence interval estimate of the mean. We're trying to find the interval estimation of a population mean at 95% confidence level. So we're going to do the following things. First, 95% confidence level means 1 minus alpha equals to 0.95. These two are same thing. Then we can calculate alpha equals to 0.05 from here. Then we can find alpha over 2 equals to 0.025. Now, what we're trying to do is, in this interval estimation of population mean, when we do not know the population standard deviation is we're going to use the t-distribution. And in this t-distribution, be careful, we're going to always use alpha over 2 equals to 0.025, which is the size of the area here. This always comes from here. So here are the steps. 95% confidence level, 1 minus alpha equals to 0.95. Alpha equals to 0.05 from here. And alpha over 2 equals to 0.025. This alpha over 2 going to be the size of this area here. This is always the case. And we're going to always use alpha over 2 for the size of the area here. Next, the degree of freedom equals to 16. We know degree of freedom equals to n minus 1 equals to 16 minus 1 equals to 15. Now we're ready to calculate this point. This point we also name it or label it as T footnote 0.025. The reason is basically we copy this number over to the footnote here. Okay, that means we're trying to find this point on the on the horizontal axis where the size of the area goes beyond this point. We label it as T footnote 0.025. Now we're ready to use the table. First of all, from the last slide, we know that the area in the upper tail equals to alpha over 2 is 0.025. Degree of freedom is a 15. So we find 15 in the first column. We find 0.025 in the row of area in upper tail here. So 0.025, and we find the value is 2.131. And that is the value of T footnote 0.025. Now we plug in numbers. From the description, we know X bar equals to 650, and T 0.025 equals to 2.131. S from the description of the problem equals to 15, N equals to 16. So we plug in those numbers, we get the confidence interval as this one. So we can interpret our result as the following. We are 95% confident that the mean rent per month for the population of the efficiency apartment within a half mile of the campus is between $620.7 and $679.3. Now let me summarize. When we saw a problem of interval estimation for population mean, first question we ask is, do we know population standard deviation? If we know the population standard deviation and n bigger than 30, then we can use this formula, which is X bar, and this is normal distribution. This is the population standard deviation. Be careful now, we need another condition is n bigger than 30. Now, if the answer to this question is we do not know the population standard deviation, then we will use the sample standard deviation S to estimate the population standard deviation sigma, and we will use T distribution here and use S here. So here is how we decide to use which formula, this one or this one. Basically, we ask the question of whether or not we know population standard deviation. If not, go this way. If yes, go this way.